Algebra 1, lesson 2.6, or module 2, page 6. So today we're talking about linear functions, and I have a number of functions graphed right here. F of x equals x squared. That's this parabola here in yellow. G of x equals the absolute value of x. That's this v basically here in the blue. H of x is negative x minus 1. That's this red here. And k of x equals this equation. That's this S curve, gentle S curve here. If you notice, all of these are functions. They all pass the vertical line test. However, only one of them is a linear function. Only one is a line, and that's going to be this red one. H of x is negative x minus 1, this red line here. So that is what we're talking about. When a function is graphed, it looks simply like a line. That is a linear function. Now, linear functions, when you write the equation, it can be written in many different formats. So here's some examples for us. Y equals 2x plus 1. That's a linear function written as an equation. 5x equals 6 plus 3y. That's also a linear equation, or even a function, linear function written as an equation. The only difference between being written as a function and being written as an equation is you have y instead of f of n, right? Also with functions, you always need to have the output by itself. Here's another form of a linear equation that looks a little different for us, but it's still a linear equation. If you notice, all of these linear equations, there is no higher powered exponent on the input value, on the x's. They're all just to the power of 1, to the singular exponent. Okay, so anytime you're going to have a linear function or equation, your input isn't going to be raised to any additional powers. It's just going to be regular. All right, so every single linear function can be graphed on a coordinate plane, and it's going to look like a line. Most of the time, these lines will cross the axes. And if you remember, let's see if I have this graphed. I do. Okay, so we have two axes. We have an x axis and a y axis. And here I have a line that's graphed. And when this line crosses one of these axes, we call it an intercept. Okay, so when it crosses the x axis, this is the x-intercept. And when it crosses the y-axis, we get a y-intercept. Okay, here's a y-intercept. Here's an x-intercept. Okay, if you notice, on this one, I have the coordinate point listed out for us. It is x0, y6. When you're looking for a y-intercept, you're looking for the y number. So you always put in 0 for the x. Same with the x-intercept. When you're looking for an x-intercept, you're looking for the x value. So the y is always going to be a 0. Okay? So you're going to keep that in mind as we solve these. Here it says every x-intercept will have a 0 for the y in its ordered pair, and the y-intercepts are where the line crosses the y-axis and will have a 0 in the x part of the ordered pair. So here's some practice for you. You should be able to pause the video and write down what is the y-intercept and the x-intercept, the ordered pair for each line, each linear function you see graphed here. Unpause when you're ready to review your work. Welcome back. So we have here the x-intercept is negative 2, 0. Right here, it's over 2, up 0. The y-intercept doesn't move to the right or the left at all. So its first value is 0, and it goes up 2, so it's a positive 2 here. That's the y-intercept. Number 2, you have the x-intercept. It's halfway between the 1 and the 2, so it's 1.5. And it doesn't go up or down because it's on the x-intercept, so it's got a 0 value for the y here. The y-intercept has an x value of 0 and a 1 value for the y. Here you have the x-intercept of 5, 0, y-intercept of 0, 4, x-intercept of 6, 0, and y-intercept of 0, negative 3. All right, so in addition to finding these intercepts, we need to be able to locate the intercepts if we don't have a graph, if we just have the equation. So if you noticed in all of those intercepts, there is a 0 in place of either the x or the y, depending on which one we are looking for. So that's how we're going to find the intercepts if we simply have the equation, is you're going to plug in the 0 for either the x or the y, and we're going to figure out how. We're going to do some examples practicing that. So here we're to find both intercepts of the equation. 4x minus 1 equals 3y plus 5. Let me get my pen ready here. All right, so 4x minus 1 equals 3y plus 5. Now, in order to find the y-intercept, I want to know, well, what is y going to be when the x value is 0? So all I have to do is plug in 0 for x and then solve for y. So 4 times 0 is 0. Minus 1 equals 3y plus 5. This is going to be negative 1 minus 5 on both sides. Minus 5. That's going to be negative 6 equals 3y. Divide by 3. And I'm going to get y equals negative 2. So what intercept is that? Well, I found a y value. So that's going to be my x-intercept is 0, comma, negative 2. I'm sorry, I found the y value, not the x value. Let me get out my eraser here. So that's going to be my y-intercept is 0, comma, negative 2, because what I found was my y value. X is 0. That means I'm not moving. If we think about it, if looking at a graph, I'm not moving to my right or my left at all. I'm simply going down 2, and it's right there. That's on the y-axis. So it's my y-intercept. Okay. Let me change colors to show my work for my x-intercept. So to find my y-intercept, I plug 0 in for x. So to find my x-intercept, I'm going to plug 0 in for y because I'm finding my x-intercept. So let me rewrite this equation. 4x minus 1 equals 3 times 0 plus 5. Okay, I'm looking for my x-intercept, so I need to leave my x in my equation. Plug in 0 for the other variable. So 4x equals 3 times 0 is 3, is 0, excuse me, plus 5 plus 1. I switch sides, so I'm going to, with my minus 1, I took it from the left side to the right side, so I'm going to change it to a plus 1. 4x equals 5 plus 1 is 6. Divide by 4. X equals 6/4. I can reduce that down to 3 halves. X equals 3 halves. So my x-intercept, that's not how you spell intercept. Look up here if you want a spelling. I'm abbreviating. Is going to be, if x equals 3.5, that's the same thing as 1.5, or you can write it as an improper fraction here, 3.5. It's not 3.5. I'm saying that incorrect. 3 halves. I apologize. 3 halves. And my y is going to be 0. So what does that look like? Well, I'm going to move a positive 3 halves, which is 1.5 right here. And I'm going to go up and down 0, because that's my output value. Okay? And my y is going to be 0. So what does that look like? Well, I'm going to move. Here's some written out work for the x-intercept. Here's written out work for the y-intercept. All right, so we talked about intercepts, x and y intercepts, but another major thing that you need to know about linear equations or linear functions is going to be the slope. Now, the slope is very important because it tells us how quickly it's rising or falling. Think of a slope on a mountain, how steep the mountain is. The steeper it is, the more the slope is going to become vertical, right? We've got no slope. Horizontal line is going to be 0. You're going to have all the way up to, if you have a vertical line, there is no slope. That's not it's not got a slope because it goes straight up and down. Excuse me. So the slope of a line is found by the change in y over the change in x. We got into that a little bit in our vocabulary unit. So remember, change is written as a triangle, the change in y over the change in x. So we're going to put change in y over change in x. Okay. So what that means is you're going to have y2 minus y1 over x2 minus x1. Now, your x and y's, it does not matter which point you choose to be point 1 or point 2, as long as whichever point you choose, you use the same y2 and x2 from the same point, and y1 and x1 come from the same point. In other words, the order that you have on the top, you have to keep that same order on the bottom. You can't mix up your orders because that's how you're going to confuse things. Now, slope is going to be called m. Now, I have people ask me all the time, why isn't it called s? I have no clue. It's just called m. I'm sure there's a reason. I just don't know it. So one way you can do it is you can count the change. If you have a graph, here we have 2 points. They're indicated by the end of the line segment here. And we're going to count the change in y. 1, 2, 3. We're going to put that on top. And the change in x. 1, 2, 3, 4, 5. That's going to go on bottom. 3 over 5. So our slope is m equals 3/5. 1, 2, 3. We're going to put that on top. And the change in x. 1, 2, 3. All right. So sometimes slope is called rise over run. That helps us remember that it's the vertical change or the change in y over the horizontal change or the change in x. Rise indicates up and down, and run indicates right to left or horizontal. Now, one thing you need to know is if you're going down when you're counting your change in the points, that's going to equal a negative number. If you're going up, that counts as a positive number. Same with horizontal change. If you're going to the right, it's a positive number. If you're going to the left, it's a negative number. Okay, so you have to remember that when you're calculating your slope, if you're using the counted out method instead of the subtraction or the formula route. You have to be aware of which direction you're moving so that you can get the proper symbol for your slope, because a negative slope is going to look like this. If you have negative, let's just say 3/2, and if you have positive 3/2, it's going to look like this one, m equals 3/2. So you can see they go in opposite directions, the slopes. A positive slope is going to go as if you're going up the mountain, and a negative slope is going to look like you're going down a mountain. Okay? It's going to look like this one. Here we have a negative slope. Let's see if we can figure out what the slope is, though. Well, we can just count it like we did before. 1, 2. I'm going to look at this dot and this dot, this point. So I went down 2. My vertical change is -2. Horizontal change was 1, a positive 1. So my slope in this case is -2 because I need to simplify my fraction, okay? And you can see that information written out right there. Here's another one for us to try. We've got 2 points given to us here. This point looks to be 3, 0. And this point looks to be -3, -4. All right. So in this case, instead of counting it out, what I want to do, I already know it's going to be a positive slope because it looks like I'm going up a mountain here. This one looked like I was going down a mountain. Okay, so up is going to be a positive slope. I want to go ahead and pick out what is going to be my point 1 and what's going to be my point 2. I'll put this as point 1 and we'll call this one point 2. All right. So remember, we want to do change in y over change in x, which means y2 minus y1 and x2 minus x1. That's the general way you're going to see it written, one of these two ways. It's also known as rise over run. Rise over run is when we count it out like that instead of using the formula. All right, so y2 minus y1. I called this point 2. So I want to look at point 2. I'm going to look at the y in point 2, which happens to be negative 4. Okay, I'm going to go ahead and write my fraction. And then I'm going to go ahead and look at my x, negative 3. You see, I'm still making sure I line up my x and my y that are in my ordered pair still need to be in an ordered pair here. I have to have the y of the same pair matching with the x from that pair directly below it. Okay. So then we have a minus here in the middle. Okay. So we're going to go ahead and put minus signs right there. Now, the next thing we need is our y1 and our x1. So I'm going to look over here at point 1. My y1 is 0, so it's going to go right there on top. And my x1 is 3. Okay, so let's look at the answers now. I've got a negative 4 minus 0 is a negative 4. And negative 3 minus 3 is going to be negative 6. Negative 4 over negative 6. Well, I've got two negatives here. What does that mean? That means I'm going to have a positive. If I have an even number of negatives here, that means my answer to a division problem is going to be a positive. Well, 4, 6. How can I simplify that? Well, if I can't do 4 divided by 6, so I have to just simplify by dividing both the denominator and the numerator by 2. Which is going to give me 4 divided by 2 is 2, 6 divided by 2 is 3. So in this case, m is going to equal 2/3. And we see that we got our answer correct right there. All right, so I want you to go ahead and pause. And this one you can do just rise over run because we don't have the ordered pairs, but it tells you what the rise is and what the run is. So go ahead and pause, show me what the slope is, and come back. All right, welcome back. Here we have a rise of 4 over a run of 2. So m is going to equal 2 because 4 divided by 2 is 2. All right, here we have a rise of 3 over a run of 3. So our slope is going to equal 1. And if you notice, those both look like they're going up a mountain, and both of our answers are positive. So we're definitely lining up logically. It makes sense. So here, this is going to be a positive answer as well. Our rise is 3, our run is 5. 3/5, I can't reduce that at all. So my slope is simply 3/5. Here, look, I've got a negative. It looks like I'm going down a mountain. So I'm going to put my rise of negative 4 over my run of 2. Negative 4 over 2, that's going to be able to be reduced. M equals negative 2. Nope. I wrote the answers exactly where the other answers were. All right. You can also find the slope if you have 2 points. And we kind of already talked about this a little bit. You identify a point 1 and a point 2, and then you find the difference in the y values over the difference in the x values. So here we have an example. The slope of a line that passes through the point 15, 8, and 10, 7. So we're going to call this first one 15.8. We're going to call that one 0.1. Oops. 0.1. And this one is going to be 0.2. So if I remember correctly, it's change in y over change in x, which is the same thing as y2 minus y1 over x2 minus x1. Okay, so 0.1 here. I'm going to write it in red. So I like to use my colored pencils or my colored pens to help me make sure everything's lined up correctly. So I want my y on top. So 8 is going to go on top, and I'm going to put 15 on the bottom. All right. And then I know I need my minus sign in the middle because that's what's in my formula, y2 minus y1. And then let me go to some green here, 10 and 7. Okay, well, what goes on top? Y goes on top. So 7 is going to go on top and 10 is going to go on the bottom. All right, so 8 minus 7, well, that's easy. That's 1. 15 minus 10 is 5. So 1/5. M equals 1/5. Okay, well, what goes on top? Y goes on top. So 7 is going to go on top. And 10 all right. Here's some practice for you. I want you to pause the video, do this practice, and come back. All right, welcome back. We're going to do the change in y over the change in x. Now, it does not matter which one you label 0.1 and which one you label 0.2. You're going to get the same answer as me. So we're going to try it both ways in case. So just so you can make sure that you got the correct answer. I want you to see that it doesn't matter which one you label as 0.1 and which one you label as 0.2. As long as you keep the y's and x's paired up, because remember, it's an ordered pair. As long as you keep it paired up, it'll be just fine. So we're going to do change in y. I'll write it up here. Change in y over change in x. Okay, so P2 minus P1. So Y2 minus Y1. Here's my Y is 5. Here's my X, -1. I know I have to have a minus in there. And here's my 0.1. I need on the top -10. So in order to write a -10 here, I'm going to write a plus 10, because instead of writing minus a negative, we know that when you minus a negative, it becomes a positive. Okay. And then the x is -5. Again, I can't subtract a negative. It's going to turn into a plus 5. All right. So that's 5 plus 10 is 15. -1 plus 5 is 4. 15/4. M equals 15/4. Well, what if I reversed it and I did P1 first instead of P2 first? So in other words, if we switch these around, okay, so let's try it. -10 minus, and then -10's on the top, so on the bottom I'm going to need -5 minus. Okay, well, in this case, y is 5 and x is -1. That's going to be a plus 1 here. All right, -10 minus 5. Okay, well, that's a -15. Well, that doesn't quite look exactly the same. Let's see how this plays out. -5 plus 1, well, that's a -4. Two negatives make a positive 15/4. So I ended up getting the same answer no matter which point I put as 0.2 and which one I put as 0.1. If you notice, it did not matter which one was first and last, as long as the numbers lined up. I had 5/1 both times, and I had 10/5 both times. Okay. So what is the slope of the line that passes through points 1, 0, and 3, 8? I'm going to go 0.1, 0.2 again. All right, so 0.2, I've got 8 as the y, 3 as the x, put a minus sign there, 0 as the y, 1 as the x. 8 minus 0 is 8, 3 minus 1 is 2, 8 divided by 2, my slope is m equals 4. All right, what is the slope of the line that passes through these 2 points? I'm going to label this point 1 this time, and this one's going to be point 2. All right, so negative, oops, nope, got to be careful. My x's don't go on the top. What goes on the top? Y's go on top. Change in y over change in x. So I'm going to start with 2 here. And negative 4 goes on the bottom. My subtraction signs are next. Y's first. Negative 3 becomes plus 3. And on the bottom, it's a positive 3. So I'm just going to write that in right next to my subtraction sign. 2 plus 3 is 5. And negative 4 minus 3, 4, 5, 6, 7, same sign. We're going to combine. So 4 plus 3 is 7. And it's going to carry the sign that was the same here. So 5 over negative 7 is the same thing as negative 5/7. And negative 4 minus 3, 4, 5. All right. Well, I hope you understand about slope and y and x intercepts for linear functions. And I will see you next time where we're going to get into some different formats for linear equations, different ways to write the line, the equation of a line that will help us find some of these things a little bit faster and easier. And I will see you next time where we're going to get into some